It is my pleasure to introduce to you our second speaker, Jiaqi Liu, who is going to speak to us about demystifying observability and monitoring. Jiaqi is a senior engineering manager at GitHub. She's passionate about bridging the gap between the science and the engineering part of data work. She is also an advocate for a culture where everyone's input matters and is active in the Right Speak Code and Women Who Code community. Today, Jiaqi will share of her experiences as a technical leader and as a platform engineer on how to incorporate observability into systems architecture and backend APIs. Please join me in welcoming Jiaqi. Jiaqi, welcome.
Thank you, Ingrid. Thank you for the warm introduction. Hello, everyone. Thank you for joining me today. My name is Jiaqi Liu. You can follow me on Twitter at Jiaqi Codes and feel free to ask questions throughout the presentation after, either on the Huba app or via Twitter. Feel free to reach me. I'm really excited to talk about observability and monitoring today. We'll get right started. I'll go through the agenda. I'm going to start with talking about software and what resilience means to me as a platform engineer, as a technical leader. Talk a little bit about observability versus monitoring, and then give a couple of examples on how I've incorporated observability in software I built in the past, and conclude with takeaways. So going with the theme of the conference, I have to talk about resilience. Software is inherently dynamic and unstable, from the site reliability engineering book, which I highly recommend. So a lot of what I've learned in my time building and maintaining software is you really can't build a system that isn't going to break. Rather, you have to become more resilient as a software engineer and in building resilient systems to recover very quickly from any failure states. So in site reliability engineering, one of the core concepts is that creating a stable system is about fast recovery and being able to quickly detect failure states and recovering from them. Much like in, philosophy and life, resilience is as much about recovery and being able to reset as it is about endurance and going and being able to build your own career path, but also reset and when there's failures or when you're tired and burning out. So I really like that parallel between resilience and site reliability. One way to achieve this level of resilience at a systems level is designing with non-functional requirements in mind. And this means that you have the proper tooling to very quickly resolve issues, the proper tooling for quick deployment, and being able to check for any kind of regressions before making a deployment. Core testing framework so that those are easily automated and you're able to have those checks happening as part of your continuous integration pipeline. Having the right monitoring, logging, alerting, and playbooks in place so that you are able to detect failure states, assess what the status is on those failure states, and then having a playbook so that anybody on your team can figure out how to recover from a given state. And last but not least, I won't talk into it too much in this presentation, but there's also a system of, frequently having auditing to make sure that you are prepared for any kind of regressions in your system, having good security and compliance in place, backing up your data, and really preparing for the worst in case of a disaster scenario. My team also has in the past done test cases where you go through a drill of what a disaster situation looks like so that when it does happen, if it does happen, you are prepared and you are able to calmly run through the playbook. And it's an excellent opportunity to sort of test the playbooks as well. So these are kind of the high level of what non-functional requirements mean. And behind the scenes, behind all the user-facing functionality, all of this, having these kind of frameworks in place allows you to recover very quickly. So I'm going to talk a little bit more into what that means in the world of observability and monitoring. So I say observability versus monitoring here, but they really go hand in hand. And I just want to start off with explaining sort of the very, minute differences between the concepts of observability and monitoring. Monitoring refers to, what you know about and what you want to be keeping track of. This is, for example, you might have metrics detecting things like how many 500 responses you're getting on your system. You might have logging in place for software, distributed tracing, working on a distributed system. It helps you gain insight on the health of the issue, and then you can alert on known issues. Successful monitoring means that you can detect known issues. In turn, observability is actually on the things that you don't necessarily know for sure. And the focus is on you're able to debug a system, able to provide tooling for developers to work on a given system. And the success metric for observability is that you should be able to understand and dig into and explain a system and its behavior without having to introduce new code to the system. So this really means that when you're building out a feature, you should also be building out the underlying non-functional requirements that will give you that level of success for observability. This blog post from Cindy Saharan illustrates the core concepts behind observability and monitoring really well, and sort of has this diagram that illustrates what falls into the scope of observability versus testing versus monitoring. Something interesting to think about here is that testing allows you to verify for correctness, and monitoring gives you a world of predictable failures that you're keeping an eye out for and that you know how to recover from. But observability is sort of everything else that may or may not cause a full or partial failure down the road, things that you won't know about because you can't possibly test for all potential failures or monitor for all potential failures. So this gives you the foundation to be able to recover from unknown and future failure states. Why has this become really important? Software systems are becoming more and more complex. A lot of this is being abstracted away for developers with a lot of the really awesome open source tooling and frameworks out there. But distributed systems are becoming more and more prevalent, and they're complex by nature. So it's getting harder and harder to predict systematic impact. You can make a change in your code base without realizing that further down the stream, it's impacting some dependencies or packages. So it's getting easier to build software, but harder and harder to predict what will happen in a live production situation, which is why monitoring and observability has such an important place in software development and will continue to have such an important place. I'm going to talk a little bit about examples on how I've leveraged monitoring with metrics-based alerting. Metrics-based alerting is not the only form of alerting. There's also log-based alerting, but I am much more familiar with metrics. The tools I have used in the past are Prometheus and Grafana. They're both open source tools. Prometheus is a time series-based metrics database that stores time series data and tracks the health of your platform. And it also allows you to configure alerts. Grafana is used to visualize this time series data and present sort of a graph so that when you're investigating a performance issue or a production incident, you have a very easy snapshot of when the trends are going and what's happening at what time it's happening at. There's, of course, other great monitoring tools, and there's also more log-based monitoring tools, like I mentioned, but I will focus more on Prometheus and Grafana for now. This is an example of a Grafana dashboard that allows the user to sort of see the general health of a Kubernetes cluster. Couple of really obvious things that you might want to be paying attention to because you're monitoring a Kubernetes cluster might be things like memory usage and CPU usage. And those are the front and center and gives you a very good glimpse into the health of the cluster right away. So having these kind of dashboards set up makes it a lot easier to gauge in a quick way, what's the health of my cluster, what's the health of my production system, what is sort of red and should be paid attention to. Prometheus, because it's focused on time series metrics, allows you to push metrics or have metrics scraped from the services to the Prometheus server. In this example, I am calculating the time it takes for a data pipeline to run and having this metric set to the current the time that the data pipeline has completed. So this metric is then being scraped by the Prometheus server and stored each time it changes as a gauge. The way it's being set is that the way that I'm running this job is I'm running it within this with job duration seconds.time. I'm running the pipeline, and once the pipeline completes, I'm running the code to set the metric in place so that it's always set once the job completes. If the job fails, this metric is not set and therefore is defaulting back to the previous time that it succeeded. This means that I can write an alert to calculate based on when the last time the job was successful. So if the last time the job was successful was within a 3-hour period, then that's tolerable for me. But if it's greater than 3 hours for the duration of 15 minutes, this alert will trigger at a severity of high and be assigned to this data platform owner with the summary and description below. So this allows me to set a threshold for here's what I expect the most recent job to have happened within the last 3 hours. And if it's beyond that, I want to be alerted. So monitoring and alerting is definitely not the only way to pay attention to these. One important aspect is actually building in features that will allow you to support observability better. Again, it's not just about using tooling provided to you, but also thinking about this when you're designing software. So there's two specific non-functional requirement type of features that I'm really excited about that I try to look for. One is building in immutable data. And having immutable data and having an immutable data model allows you to reproduce outcomes. And this allows you to, going back to the beginning on the goals of observability, allows you to understand what's going on without necessarily deploying new code. What is immutable data and what does it mean to structure something in a way where you can have immutable data? In this example, I'm presenting sort of a list of transactions. Let's say that this is a bank account, and sort of instead of storing a user's balance at any given point in time, this is just storing a history of their transactions. And this will allow you to calculate the balance at any given point in time, but also sort of go back to a point in the past and say, maybe calculate balance at a previous point in time and have that sort of reproducible way to calculate data and look at data from one point of time to another. Another thing that I look for, especially working with data, is lineage. And this allows you to, again, diagnose your system, diagnose your software without hopefully adding new code or new logic in to look back. And data lineage simply means being able to know where your data source came from. So if you're looking at a transaction and you made several calculations, oops, sorry about that, several calculations about the user's data, you want to know where your source of information is coming from. how do you get this data lineage? You can tag records with metadata. So kind of like think about version control, think about tagging records with this is the code that generated this metadata. You can use logging to a distributed tracer and use consistent unique identifiers to track your data across systems, across the way that it's getting transformed. So here's just a couple of tips, but there's actually quite a lot of ways that you can work with to create data lineage that works for you. One thing to note here is you want to keep this fairly simple. Metadata should be light and it shouldn't bring overhead to your overall systems. I just want to conclude with that observability allows you to build resilient systems because you can then quickly recover from any failure states. It doesn't mean that all unknown failures are prevented or that you are able to, completely minimize outages, but it does allow you to recover quickly, which should be and learn from your systems, which should be a goal of software design. One takeaway, if any, that you bring out of this, it's really important when planning roadmaps and when planning features to make time for the process behind incident management, disaster recovery, being able to bring data lineage and systems to a visible front so that developers monitoring the system knows what's going on and can debug the system, and create space for some of these non-functional requirements, which are not trivial. And I think this is a big lesson for me in building and maintaining software. Sometimes it's very easy to plan for the feature without necessarily thinking about what are we doing behind the scenes to make it easier to maintain so that we be freed up to build new features instead of maintaining existing systems. And last but not least, it can be really hard to identify the key non-functional features that you need to reduce the effort to maintain systems and make it easier to maintain software, but also to build new features. I have in my time working with data and data platforms identified that it's important to create data lineage and use immutable data wherever possible. But there's definitely different types of software out there for which you might want to build up the foundations for what are the important non-functional features that are needed for the platforms that you're working with. And thank you so much for coming to my talk. Feel free to happy to take questions. And yeah, I'm excited to share more about observability with this group.
Thank you so much. So Ingrid, I'm going to hand it off to you for the next intro.
Thank you again, Irma. Hello again, everyone. So it is definitely my pleasure to introduce to you our third speaker, Khushbu Kashyap, who is going to speak to us about jumpstarting your cybersecurity risk program, a paradigm shift. With
Okay, it looks like we lost Ingrid a little bit. So Khushbu, let's go ahead and have you get started.
Okay, thanks, Irma. I was just making sure it's not just me. But just to give you a very quick introduction about myself, my name is Khushbu Kashyap. I work for Rubrik as a senior manager in the information security space, specifically in the GRC front, where I manage some pillars, including risk management. Prior to Rubrik, I actually started my career as a software developer. So that's very much ingrained in how I run things or how I build risk management functions, which is going to be the core of our talk. I also want to highlight I have about half a decade to a decade of experience in Big Four consulting, working with a lot of technology, fintech, financial services companies in the Bay Area, Seattle, UK, and Australia as well. Now, going to our topic here around risk management, before we go into the topic itself, I wanted to give you a very brief overview about Rubrik, because it sets the context of why we designed our risk management program in a specific way here. So Rubrik is a cloud data management company in the enterprise backup recovery space. Its products and services in data protection, ransomware recovery, and it has a lot of protective services around data protection, along with enterprise backup recovery, and it helps companies to achieve regulatory compliance. Now, this gives you an idea that I was creating the security function in an already security and tech savvy company, having a lot of engineering heavy cloud native technologies present. It also didn't help a lot from coming from a process background that our company had a very progressive and future-looking technology stack. And of course, some of the smartest people in the industry to work with. It came with its own set of challenges and opportunities that we'll go into shortly. But with this primer, let's dive into our session topic, a paradigm shift in cybersecurity risk program, where I'll be sharing with you how you can jumpstart your own risk management program from inception to operations within a year. Now, in order to aid your understanding on what a cybersecurity risk management program is, I'll be using some of these diagrams that you'll see in the upcoming slides as well. Now, my purpose of this slide is to not bore you with the process. I promise I simply want to introduce you to some key cybersecurity risk management terms and areas when it comes to the process. We need to think about it as a process, data, and technology-enabled risk management function or a capability. The goal is to be essentially give you the tools and technologies and data structure behind to identify, assess, respond to, monitor, and report out on risks. One thing to note here is that as we have been building this capability here, our considerations have been to build an agile, lightweight, and easy to adopt friendly process without too many gates. I also want to highlight here that cybersecurity risk management is not merely a regulatory requirement, because if set up well, it acts as a core of an information security program and strategy. Like any risk management function, it is designed to be an enabling function, be it within our information security team or with other business stakeholders and orgs. It helps different parts of the organizations in different layers, as you see. For example, here on the screen, the lower level program components help with the operations. So these are our tactical day-to-day operational risk and control decisions based on, of course, discrete use cases. On the middle layer, here you have the management with the different engineering teams, IT teams, product teams who work on security risk. Now here we help them do strategic planning, project portfolio, resource allocation, and also help them with investment strategy as to how they need to make sure how to include security as part of all their processes. And on top of the pyramid is risk oversight. Now, this is about fiduciary oversight, mostly handled by your e-staff, your executives, your board of directors. And here we deal with business risk, not just security risk, but what does it mean in the business terms, how to identify your priorities, and how to inform your strategy. Going to the next slide here. Now, I would like to give you some additional situation context here. In a typical security team in any organization, there are multiple interrelated disciplines which are operating in a federated manner. On one hand, you have your agile and DevOps mindset of the engineering and product teams. And on the other hand, you have the security gate barriers, sometimes enforced by the GRC teams in security. On top of this, you have your executives who want more real-time, transparent reporting beyond what a traditional security or enterprise risk management function may be providing today. In the end of the day, risk or security risk need to sit at the center of the board and senior executive agenda. Now, Rubrik is a high-tech, high-growth company. We have some unique considerations. Our process needs to mirror a typical engineering process. It needs to have some key parameters that we need to keep in mind as we're developing it, which are agility. It needs to be super lightweight, not process heavy. There needs to be ease in adoption and follow through with engineering. Without taking care of these unique considerations, a fast and free-flowing freeway infrastructure can easily look like this. Now, in order to ensure that doesn't happen to any of your programs, I want to walk you through the same pyramid that we saw earlier, but now from an engineering and data perspective. And starting that journey, first, I want us to focus on a comprehensive strategy of people, process, and technology. And on the same hand, we would need to ensure that the traditional process-heavy function has a technology and data-heavy backend to support the evolving needs. And to start with data, let's start with the data discovery exercise. Here, we need to identify the right data sources. We need to think about the technology, why we are doing it, or what are our goals around it. So in terms of the data types of the whole risk management program, which is almost like the foundation structure for the risk management program, we need to think about security gaps, industry threats, any security vulnerabilities, either in our product services or in our internal infrastructure. We need to understand our security reviews, issues, policy exceptions. And all these data items actually exist in a complete disarray of many technologies out there. So now you have to think about the technology, understand where this data exists today. Is that the right place for that data to exist? Do we need to build a database or a warehouse to centralize this data in order to benefit from the contextualization that happens with it? For example, there may be a ticketing system just like Jira, which may be used in a lot of organizations or your organization. You need to think if all the different issues which are trickling down into the security workflow, do they exist there or someplace else like a wiki or something? By understanding this, we can either centralize all those data points in a common data system, which you're already using, or you need to think about an engineering effort in which you need to contextualize this information in a separate data warehouse. And that's key, because in the end of the day, our goal at this layer is to expand coverage. We not only should be aware of the known knowns within the organization, but also known unknowns and unknown unknowns. So for that, now that we have completed the data discovery exercise, we move on to the next phase, which is analytics and planning stage. The main goal behind this is to drive visibility and automation. Now, for this, we need a true orchestration platform. There are two things to consider here, as I said, data analytics and data orchestration. Now, what happens in this stage is because you are identifying and defining security risk ownership, for that data analytics help from the bottom layer. What are the insights we need to generate? What are we learning from the data that we have already identified in the bottommost layer? Are we able to identify the right risk items? Are we able to prioritize them in the right way? Is this the elements of the data which are going to help your engineering teams and your product teams to be able to inform their sprint planning to prioritize on the right risk or not? So for all this, of course, you need the analytics engine, which needs to be on this layer. But along with that, also think about workflow automation. Why should you have a team of so many PMs helping you out just to make sure the teams are doing the right thing, but also making sure they are meeting the timelines? You can give your PMs more meaningful tasks of giving them the ability to go meet with the team members, ask them why something is not done, but not do very mundane tasks like, hey, your deadline is coming up, can you please complete it? A lot of these things can actually be automated using workflow automations from a tool orchestration software, as I was telling you. In our company, we have been using LevelOps for this. You can use any kind of engines for it. The main use case is make your engine to have orchestration to automate a lot of the workflows, which can be automated, and use the same communication channels that engineers use. Don't email them, don't set up alerts on emails if they don't look at emails a lot of time. If they use a communication platform like Slack, maybe use that. So depending upon what your organization uses to communicate with each other, based on really these teams who are fixing the risks, who are fixing the issues, who are doing the work, make sure you're using the same platforms. And whatever automations you do end up providing or end up setting up, make sure it's integrated with those, because it really needs to be their function and you're just enabling it. By doing this, we are able to engage the stakeholders, we are able to drive ownership and accountability, and you're doing all of that through improved transparency. And that really hones in on the trust you want to develop in this enabling function with the different teams. Now that we have covered data analytics and data orchestration, we move to our next topic of visualization. In order to drive strategic insights and enable continuous monitoring, here we focus on data visualization. Now going a higher level for our business unit managers, our team leads, our VPs, we have to start creating contextualized dashboards in any kind of software like Microsoft Power BI or Tableau. Here we have to start communicating the so what around the risk. Just the operational stuff which used to help us out in terms of, hey, these risks are not getting remediated, or hey, these issues are coming up more and more often. Do we want to look into the root causes? Now you have to start talking about, these are the key things we want your teams to focus on, and here is why. And the why can be informed based on quantified numbers. It could be dollar-based numbers that this is the risk your team or rubric or your company is sitting upon because they may actualize themselves, or this is the customer liability that we are incurring because of these risks. There can be multiple ways of explaining the so what, but at this layer, your visualization engine needs to marry the so what elements as well as what we are seeing in the data together. Some key things to consider on this stage is, what is the purpose? You want to engage with your teams, you want to drive ownership, but even more important at this stage is to drive prioritization of the most risky or critical issues and risks for the company. For effective prioritization and escalation to work, what's needed is to establish consistency for assessing and prioritizing these issues. And of course, facilitating reporting for different audience types. We need to understand who our audience is. How do they like to consume information? How detailed oriented or not so detailed oriented are they? Do they like business information? Do they care about the so what? Or do they really care more about exactly what vulnerability is, exactly what issue is, how open our network is? You really have to do those trade-offs, understand your audience, and that's how your dashboard should look like. And because that's how it will make the most impact, because it will help them connect the dots better. Now, in this traditionally process-heavy function, we'll go back to the process a little bit, having now talked about the technology and the data elements. Here, our goal is to drive insights for even higher level reporting, which is our board of directors or for senior executive consumption. Now that we come to the top of the pyramid, the topmost layer is the board and management suite. They don't care about how you're getting visibility. They don't care about what you're getting visibility on, how detailed and great your dashboards are. All they want to understand is, do they need to worry about any critical risks which are in the company? Do they need to provide what oversight they need to provide on them? What do you need from them? Do they have to trickle down some to-dos or some action plans or set the tone for security for the company? And most often than not, this kind of reporting is done in the form of presentations or Word documents or PDFs. Now we move away slightly from the technology aspect at this layer, but this really sums up your whole risk management function. Now in this part of the presentation, let's take a look at how you can adopt everything you have learned so far today in your own risk management program or in your own operations. In the short term or in next week, you should be able to assess how you are communicating the value and focus of your program. Do you discuss technology without capabilities? Do you discuss capabilities without security risks? I highly recommend framing the discussions from security risks to security capabilities or services that you provide to the company, to the technology, what technology is used, and how you can also, more importantly, use technology to enable your function. In midterm or the first 3 months following this presentation, you should be able to begin your culture change to risk management, which is essentially, let's perform the risk assessment. Let's drive ownership within the different teams in order to effectively get to risk reduction. Now, in the longer term or within 6 months, you should be able to articulate a response to 3 most important or main questions. What are our risks for the company? What are we doing about it? And is it enough? So remember, start small, scale iteratively, and have a focus on striving for continuous improvement. There is really no need to strive perfection when you're building out the program. You can literally start from, let's just get all our data sets together in one place. Let's contextualize them. Let's find insights and drive analytics on top of them. Let's see what we are seeing, what can be the root cause for a lot of the things that you're seeing in a repeated manner or a repeated fashion. What can you do about them? Let's start meeting with the most important teams, which is going to help with risk reduction for the most important or the most area within the company. It's important to fail fast and make mistakes and learn from them at this step, because you also want to align on this one key thing that you need to start with the right stakeholders. Based on your program needs, try to identify these stakeholders within the company who will also benefit from risk management. They are seeing a lot of vulnerabilities, for example, in their space, or they're starting a compliance program where you can easily fit your own program with them and help them out. Starting with the right stakeholders is key, because once you gain their trust to have their sponsorship, they'll help you continue to find allies in this journey within the organization as well. And of course, you need to have your eyesight and your goals aligned to spreading awareness on the need for your company to make risk-based decisions in security. And as you're making those discussions, are they actually based on actual data and facts? And make sure that you're not thinking about risk management as a process, but a technology-enabled function which can benefit a lot from orchestration, workflow automation, analytics, insights, and automation sitting on all of this, so that you can spend more time on having more effective discussions, gaining more visibility with leadership, making sure that everyone understands risk within the company, everyone is speaking in the same language, and they're focusing their time and attention on the most needed things. Thank you. I'll stay on if you have any questions at all, and thank you so much.
Thank you, Khushbu. So if anybody has any questions, you can absolutely put them in the chat or in the Q&A tab. Doesn't look like we have anything submitted at the moment. So if you want to, will you be doing a community space to be available for questions?
Yeah, absolutely. I can stay on.
Okay, awesome. So if you want to talk with Khushbu, please go to the community page, and I believe she does have a session in there. And if not, I think we are done for today. So thank you so much, everybody who participated in this technical track. We really do appreciate it. Have a good one, everybody.